I'm Professor David Cohen, a Chief Research Scientist at the Institute of Environmental Research at ANSTO. Well, fine particles are very important. There are several key issues as to why you should study them. They're absorbed deeply into the lungs and the system and have health impacts. They affect visibility and they are transported long range, long distances. They don't worry about boundaries or borders between countries. They're also recently important in climate change studies, along with greenhouse gases. They affect climate change. The fine particles that we look at are 2.5 microns in diameter. That is, you could put 50 of them side by side across the diameter of a human hair. So they're very, very small. And basically they come from combustion products. So when you burn coal, you generate particles. When you get in your car and you drive it, diesel cars particularly, buses, you generate particles that go up into the atmosphere. Well, in order to do this type of study, we have to do two things. We have to first of all sample the air, and then secondly we have to analyse what we've sampled. 200 or 300 a month come into this machine behind me, and they get analysed automatically by a process of firing these protons through and detecting the products that we come off from. And at any one time there's about 25 different sampling sites in Sydney and also in Asia, around the world, where we're doing this. So once we've characterised the filter paper, we can then start to produce fingerprints of the sources that generated this pollution. And the process requires us to, one, identify what is in the filter paper. So we can look for silicon from soil, we can look from sodium, chlorine from sea spray, we can look from a whole range of things from motor vehicles, organics, like carbon, from soot from vehicles. And we look at all these elements, and then the quantity of these is just by counting the number of X-rays or the number of gamma rays that gives us the concentration. So the process with the machines we have here are exceedingly sensitive and very fast. Once we understand what the fingerprints of the sources are, and we have the source fingerprints, and we know the contributions to the total mass, the next question is, well, where are these sources? Where do they come from? Because we can analyse hundreds of samples from many different sites, we have the potential to cover fairly large areas. We're not just looking locally anymore. We're not just measuring what's happening here at ANSTO. We can actually look at what happens within a state and within a country. And for instance, we've done a lot of work up in Vietnam and looked at 30 or 40 different polluting power stations from China, which are polluting in Hanoi, which is 2,000 kilometres away. So we can look at this long-range transport of these things, and so we better understand where this pollution is coming from, not just on a local scale, but also a regional scale and even a global scale. And this means that we can start to talk to people, environmental agencies and environmental managers, and say, look, this pollution that you're measuring in your country is generated locally, regionally and globally. There aren't too many machines that non-destructively can analyse for 25 elements in 5 minutes. On samples, as I've mentioned here, there are only 300 micrograms, 300 millionths of a gram in size, and give you the sample back, not destroyed later on. And so we started a program back in 1990 now to do this, and it's still going now, and it will still continue to go, because air pollution is still an issue around the world, and especially through Asia. And so these machines we have here are ideally suited to do hundreds of samples a month, and no other machines can compete with that.